My name is Grant. I work on a project called Phi. It's a language. It's a Rust-like language that the compiler is implemented in Rust and it targets EVM. I work at the Ethereum Foundation, and there's 3 others on the team. So yeah, basically in this short amount of time, I want to introduce you to the language and help you find useful resources. If you want to take a picture, I've written this up just in the minutes before. This is like all the stuff that I'll be covering. So if you want to learn about a language, you can go to philang.org. There you'll find these top right tabs. You'll find a link to our Discord, and under Learn, you'll find our documentation. So a lot of the stuff I'll be covering is here. Also, you can find the binary for the latest version on the front page. So to get started, you can just download that. But yeah, I highly recommend taking a picture of this if you're interested in working on Phi. We're offering 5K in prizes. Those are bounties for you to simply implement something in Phi. Considering the features that we support, you might find yourself in an advantage using our language, and you could maybe cash out pretty good here. Yeah, so I will just demonstrate the compiler real quick. So typically you'd go through here, you download it, and then you put it on your system path or whatever. But for the sake of this, I'll just have the binary in my in the directory that I'm working in, and we'll do that. Okay, so this is what it looks like when you execute the binary. You get the types of commands that you would expect to find in a compiler CLI. Build, that's for building your project, building the contract artifacts. Check, that's for performing analysis. So if you're just interested in the type checking results. New for creating a new project. Test for testing your project. We provide a built-in test runner built on top of our EVM. That's the same test runner that Foundry uses, but we just distribute it with the CLI. And then we recently added this verification stuff for on-chain verification. If you want to create a project with some boilerplate code in there, you can just run the CLI, new, come up with a name. You don't need those. Do my project. Okay, so now I've got a new project. Quickly go over the directory structure here. So if you're familiar with Rust, you'll know that there's a toml file in the root of your project directory. That is the manifest of your project. So that describes what the project is. So it gives a name, a version, and also dependencies. So we support file system dependencies. At some point we'll add like a package manager and stuff, but if you want to add some sort of library or something, you can add that under your dependencies, and it'll just compile right into the project. It's a pretty advanced system. We support circular dependencies. Basically, we're using the basis of the Rust analyzer, which isn't even being used in the Rust C compiler. So yeah, that'll all work pretty well. We support structs, enums with pattern matching. We support generics. So yeah, let me just get into it. So now we have this project. Let's take a look at the source directory. Now what you'll see here is we're importing a module, utils, here. This utils provides, oh, you can't see this at all. I'm sorry. Okay, well that's good enough. Yeah, you guys couldn't even see the CLI stuff either. That's too bad. Okay, what time is it? I've still got time. Yeah, so here's just a simple utils module. You can imagine you're working on a project. You don't want to stuff everything in one file. It seems like the standard for a lot of development in this ecosystem is you just copy and paste things into a file. That's not really acceptable here. So yeah, say you want to put something in utils. You can write your utility functions. You could create your utility structs, enums, traits, whatever you want, and define them as public. So if you want something to be exported from a module, you need to define it as public. You can also write tests inside of a module and execute those with the test subcommand. In the main file in this project, we've just generated this main contract, which just exposes a get42 function. So contracts in Phi are pretty similar to Solidity contracts. This is not like a design that we're committing to long term, but people are just used to this contract design, so we've just implemented it in a very similar way to Solidity. At some point we would like to provide alternatives, but right now we're just sticking with this because it's easy and there's really not a whole lot of downsides to it. So yeah, public functions conform to the same encoding and decoding that you'll find in Solidity contracts. And yeah, so basically what we have here is we have this public function being exposed on the contract, which can be called, and we're just using this get42 util function. In the util file, it's called get42, but we support, renaming things, which is kind of nice. Yeah, so now we'll just we'll go ahead and do some testing. Okay, so as you can see, both of these tests are passing. So in this test main, what we're doing is we're creating a contract. Now we're using this context type to create the contract, and that's defined in the standard library. We're not importing it because it's included in the prelude, but if you wanted to see exactly how context works, you can go to our repository, you can look in the crates library folder, and you'll find the standard library definitions. Yeah. Also, you can see we have explicit mutability semantics, which is very nice. It can really help you with writing code that behaves in a predictable way. We have some compiler magic taking place right here. Context is also treated like a special object in certain cases. Basically, we have this create function, which is defined on contract types, and you can call it. You just have to pass an immutable instance of context. Yeah, in order for us to have a full language implementation of contract creation, we're going to need a more advanced type system. So this is just one of those cases where in order to provide a palatable user experience, we need to build something into the compiler. But in this test, what we're doing is we are creating an instance, or we're deploying an instance of this main contract, and then we're calling it. Yeah, so now let me just show you what happens if we break something. There are some downsides to the test runner. Basically, when something reverts, we just spit out the revert message. So that's going to be the same encoding format of the error message that Solidity uses, but we just haven't gotten around to decoding of things. If you wanted to say, debug your program, you can create an event. And I won't get too much into the specifics here, but everything that I'm doing here is explained in the documentation. And I'll also just introduce maybe a few errors to demonstrate what, here, I'll just make this the wrong type, and then we'll see what nope. I put that in the wrong one, sorry. I meant to do that in the main.phi test. So let me just move this over real quick. Okay, now we should get a compiler message here. Can you guys still see that? Looks like it's fine. Yeah, so we have something that's really important in general when you're designing a language is to provide error messages that can be easily understood, and that's a high priority of ours. Yeah, so pretty straightforward explanation as to what we're supposed to do here. Bool is used here as a value, but it expects a U256. Oh, sorry. Kind of on autopilot here. Yeah, it expected bool. It expected type U256, but it got a bool. Yeah. Okay, so we'll fix that error, and then we'll look at the, we'll run it. So it's saying the test has failed, again. Let me just quick fix that so we can get that noise out of there. This is something in the last hackathon that people, this is something in the hackathon that we were at last, people asked for, basically just being able to debug tests, and something that we added. I didn't save this, unfortunately. There we go. So we're not seeing that event yet. In order to do that, we need to pass in the logs flag. So we'll decode the logs for you here. So if you end up using fee in your project, this is just a helpful thing that you might want to look into. Yeah, let's see, 9 minutes left. So, oops. Yeah, so we're getting this nice syntax highlighting in VS Code. This makes it a lot easier to see what you're doing. If you want this as well, you're going to need to get the fee VS Code extension. And what we have a few VS Code extensions out there because we've had a few different developers create them. But as of right now, there's only one that's working, and that's the one that's created by Fee-Lang developers and is on version 0.02. So yeah, if you want to get this, you can just download the extension, but make sure you get the right one. Again, that's Fee-Lang developers. All right, let's see if there's anything else that I wanted to go over. Yeah, so let me just reiterate again, we have 3 prizes. It's all split between 5K. So yeah, we're just asking that you use fee in your project. Or you could, just target fee. And yeah, maybe since we support libraries, you could write something like a cryptography library. You could maybe implement a memory map type, things that are generally useful. These are the kinds of things that we would really like to see as hackathon submissions. But if you just feel like using fee for an application, that's definitely something that we'll consider too. Yeah, and if you, is anyone here familiar with the MD book documentation format? Yeah, so it's really nice. This is, something that Rust has popularized. Say you want to look into deploying a fee project with Foundry. You can just go to our documentation, search Foundry. You'll find a quick start guide. You can also write tests, in Foundry on contracts, so you can reuse a lot of that tooling here. The test runner that we support that's built into the compiler, that doesn't really have anything to do with this. This is just a separate thing. But since so many people are familiar with Foundry, we've made sure to integrate with their existing tooling. Yeah, and then if you find yourself really deep in the weeds and the documentation is not helping you with your project, you can go to our repository if it loads. And go into this crates directory. Here you can find the standard library implementation. You can also find a whole suite of tests, mostly testing the standard library. So you can find use of precompiles in fee. Obviously precompiles, and you can't see any of this, I keep forgetting. Let me zoom it. Let me zoom in. Yeah, so say you want to see how you'll work with any of the precompiles, you can just go into our test directory, crates test directory, and you can find usages of all the precompiles. Here's the use of EC recover. We have labeled parameters, so yeah, anytime you want to call a function, if it requires that you label parameters, then you have to do that. It ends up making the code look a lot more readable, especially when you're dealing with a function like send a value or something, where you just have all these random parameters. I, for one, can never remember what order they're in, what anything means. So just having the compiler check to make sure that you're passing in the parameter that you expect is really nice. Well, yeah, does anyone have any questions?
How can I interact with Solidity existing contracts?
Yeah, so we conform to the Solidity ABI. There are distinctions between the Solidity type system and the fee type system. Ultimately, we would like to have a library that provides full support for interacting with Solidity contracts. But as of right now, you'll find limitations when it comes to like dynamically sized things. I know there are workarounds. You can figure out solutions to things, but generally, like, you know, statically sized things work totally fine. And then, yeah, there can be some issues with dynamically sized things. In Phi, you can define a call function, which you can find if you were to search. Are you familiar with like the underscore like syntax in Python, where it's like underscore underscore like that? That's the syntax for both constructor and this call function, because they're kind of like these special case functions which you can define in a contract. So right, like the underscore init function allows you to define the initialization of the contract, and then the call function allows you to define the call handler for the function. So say you just want to totally bypass the Solidity, or the contract ABI that Solidity uses, you can just write a call function, you can define a call data reader, and then you can just decode against that call data reader however you want. So, you know, if you were to write a function that is, you know, if you absolutely needed to write something that handled a dynamically sized data, you can do it that way.
Is there any language server protocol implementation now?
Are there what?
Language server protocols, like
Yeah, so we're working on one, but it's dependent on a we're working on one, but it's dependent on a refactor of the front end. But yeah, we do have someone that is dedicating half time to it, and it's very good progress. So we hope to roll that out in the next 3 months to 6 months.
what functionality does the VS Code plugin have? Only syntax highlighting or something?
Only syntax highlighting, that's correct. Yeah, he's asking about language server protocol. We're working on one. Currently, the VS Code plugin just supports syntax highlighting. Slightly higher, I'd say. Yeah. But again, yeah, he's asking where does the gas consumption sit? Slightly higher. But so in our standard library, we provide an EVM module, which provides direct access to all of the opcodes that are provided in UL. So if you want to write something that's pretty close to assembly, you can just do that. The higher level abstractions, since we're kind of a younger language, haven't been fully smoothed out, so there might be some inefficiency there. Yeah, so one more question if anyone has one.
How can I interact with contracts from frontend? Can I generate API or like Solidity and communicate this contract from frontend from JavaScript?
Well, yeah, I mean, I would recommend, okay, so he's asking how can you interact with the fee contract. Yeah, so we generate a JSON ABI, right? And again, we've kind of like hooked into some existing Solidity Foundry tooling. So I would recommend using Foundry for something like that. And you just, you know, you won't have any issues because we conform to the same contract model as Solidity. All right, thank you very much.